Hey everybody, in this video for section 11.1 of your book, the square root properties and completing the square, we're going to be talking about how to solve a quadratic equation of a certain form or certain form. So let's take a look at that. By definition, a quadratic equation is of the form ax squared plus bx plus c equals 0, where the leading coefficient a is non-zero, because if a is 0, this entire term is gone and we're just left with a line or a linear equation. So in order to be quadratic, we have to have that other term there. Now, to solve this, previously we would solve this by factoring and using what's called the zero product property, which is still perfectly okay for you to use. Let's review that briefly. Example, if I had something like x squared minus x minus 6 equals 0, we would factor this as maybe x minus 3 times x plus 2 equals 0. And then because this is now a product instead of a bunch of addition and subtraction, we can break this up into two different equations. The zero product property says if you have two things multiplied together and it equals 0, then either a equals 0 or b equals 0 or both. So what we would have here, let me erase this here. What we have here is two separate equations then. Either x minus 3 is the culprit and equals 0, or x plus 2 is equal to 0, in which case we can solve each one of those separately, and x is equal to 3 or x is equal to negative 2, and we would have two answers here when we present our solution set. X is equal to 3 or negative 2, or sometimes we would write that in squirrely braces as a collection of numbers 3 and negative 2. That's what we used to do. But that really depends upon your ability to factor something like this. Can you factor that? And the answer to that question more often than not is probably going to be no. So let's take a look at another type of technique. And this type of technique works in a specific situation. So let's talk about situation number 1. Okay? Situation number 1 is when you have something of the form ax squared plus bx plus c equals 0. By the way, this is referred to as the standard form for a quadratic equation. You always want to get it in this form before you start solving for anything. Situation 1 is when b is equal to 0. That makes this ax squared plus bx plus c equals 0, where specifically b is 0. And we can then simplify this to just be ax squared plus c equals 0. And now we can solve this directly using what's called the square root property. So what you want to do for this is, number 1, isolate the squared quantity. Now in this particular case, that's just the x squared term. A isn't squared, it's just a coefficient. And so what we're going to do here is we're going to take a x squared plus c equals 0, and we're going to subtract c from both sides, so that we have ax squared is equal to negative c. And then we'll divide both sides by a, giving us x squared is equal to negative c over a. And now, once we have isolated the square, we're going to use what's called the square root property. And the square root property says the following. Excuse me. If you have something squared equal to something else, like w squared equals k, if this is true, then w is equal to plus or minus the square root of k. So effectively what we've done there is we've taken this expression w squared equals k, and we have undone the square by taking the square root of both sides. And on the left side we just get w, but on the right side what we get is, because we're taking a square root, plus or minus the square root of whatever k is. So in our case, we have if x squared is equal to negative c over a, then x is equal to plus or minus the square root of whatever negative c over a is. Now, in this particular case, I don't know what c and a are, so I really can't go any further. I can't even tell you if it's positive or negative. And it could very well be negative, in which case you're going to have to deal with imaginary numbers and complex numbers like we did in Chapter 10, so keep that in mind. Let's take a look at some examples of using the square root property, and then I guess step 3 would be simplify the radical, if possible, and solve the resulting equation. Now in this particular case, I guess the resulting equation is already solved because we have x all by itself, but that's not always going to be the case. So let's take a look at some examples. Example number 1, solve for w. So let's see here. Suppose w squared minus 72 is equal to 0. Well, our first step is going to be to isolate the squared quantity, and in this case that's just w squared. So we'll add 72 to both sides and we'll get w squared is equal to 72. Step 2, we'll use the square root property, and that says if w squared is equal to 72, then w is equal to plus or minus whatever the square root of 72 is. Now we can simplify that a little bit. This is plus or minus, let's see, 72 is 36 times 2. So this is plus or minus the square root of 36 times the square root of 2, which is just plus or minus 6 root 2. And that's about as simplified as it's going to get. And step 3, it is, I guess I just did that, simplified and solve. There's not much left to solve for here. We've already got w. W is equal to plus or minus 6 root 2. And that is our answer. So, there it is. That's an easy one in a nutshell. I guess the hardest part was the fact that 72 wasn't a perfect square there. Let's try another one. Example number 2. Solve for t, where t is buried in the equation 4t squared plus 9 is equal to 27. So what are we going to do here? Well, what we want to do is note that if we were to put this into standard form, that would be some kind of at squared plus bt plus c equals 0. This would be 4t squared plus 0t, and then minus 18 equals 0. And we would note that our b value is equal to 0 here, so we can use the technique above. So what we're going to do here is isolate the square, in this case t squared. That's step 1. Oops. Quit writing with the highlighter, Jenkins. Step 1, isolate t squared. That's the square. And so if we take 4t squared minus 18 equal to 0, we'll add 18 to both sides. And then we'll divide both sides by 4 and get t squared is equal to 18 over 4, or 9 halves. So this is the 2-step for isolating the square here. We added 18 to both sides, and then we divided by 4. And so step 2, now that we have the t squared isolated, is going to be to use the square root property, which says if t squared is equal to 9 halves, then t is equal to plus or minus the square root of 9 halves. So in step 3, we're going to simplify and solve. By simplify, I mean simplify the radical. By solve, I mean solve for t, but we already have t solved for because it's isolated on the left. So we have t equal to plus or minus the square root of 9 halves is equal to plus or minus the square root of 9 over the square root of 2. And then we'll rationalize the denominator by multiplying top and bottom by the square root of 2, which makes this plus or minus the square root of, well, let's see. In the bottom, we're just going to get 2. The square root of 9 is 3, and the square root of 2 can't be simplified, so this guy is 3. We just get a 3 root 2 over 2. So t is equal to plus or minus the square root of 3 over 2. Let me write that a little bit better. Sorry. 3 root 2 over 2. And that's actually two answers. T equals 3 root 2 over 2 or negative 3 root 2 over 2. Or if you wanted to write that as a set, you could write 3 root 2 over 2, negative 3 root 2 over 2, and those squirrely braces there. Okay. All right, let's up the dose a little bit. Example number 3. Solve for a, where a plus 12 squared plus 4 is equal to 0, or the quantity a plus 12 squared plus 4 equals 0. So now this one's a little bit different. Our entire squared term is the a plus 12 squared, so it's not just a single variable squared. So step 1, when we isolate the square, all we need to do here is subtract 4 from both sides, and we have a plus 12 quantity squared is equal to negative 4. So that's done. Check. Nailed it. 2, square root property. If a plus 12 quantity squared is equal to negative 4, then a plus 12 is plus or minus the square root of negative 4. And it used to be, before chapter 10, you would say something like, you can't take the square root of negative 4, Jenkins. You can't fool me. Well, now you can. A plus 12 is plus or minus 2i. Remember that that's plus or minus the square root of 4 times the square root of negative 1. And the square root of negative 1 is I, and the square root of 4 is 2. So that's what we get. And then finally, 3. I guess this is part of step 3. Simplify and solve. So let me just duplicate this, move this down, erase this guy. Oops, delete. So there was my simplification, and now we need to solve. And we're going to solve by subtracting 12 from both sides. A is equal to negative 12 plus or minus 2i. And that's the best we can do. This cannot be simplified. Remember that these are not like terms. We cannot add those together. So really there's two answers here, negative 12 plus 2i and negative 12 minus 2i. But we use that plus minus notation to use shorthand for representing our answers. Okay. Man, you guys are so good at this. Oh my gosh. You guys are so good. Okay, so let's see here. What do we got? Let's go down here and start a new page. Example number 4. Solve for p, where 3p minus 7 quantity squared minus 18 is equal to 0. So let's see. I would say don't FOIL this out. That would be bad here. You would just make things super nasty. Instead, what will make us happy is if you solve, whoa, easy, buddy. if you solve for 3p minus 7 squared. So step 1, isolate the square. So we can do that by adding 18 to both sides, and we're going to get 3p minus 7 squared is equal to 18. All right. Step number 2, use the square root property. So if 3p minus 7 squared is equal to 18, then 3p minus 7 is plus or minus the square root of 18. And step number 3, simplify and solve. Okay, so what are we going to do here? Let's see. 3p minus 7 is plus or minus. I can rewrite 18 as 9 times 2. So this is plus or minus the square root of 9 times the square root of 2, which is plus or minus 3 root 2. And that tells me that 3p minus 7 is plus or minus 3 root 2. Or 3p is equal to positive 7 plus or minus 3 root 2. We cannot combine these because they're not like terms. Not like terms. And then we can divide both sides by 3, and that's just going to be wholesale across the board. Divide by 3. Now we can break that up into 2 terms. That's 7/3 plus 3 root 2 over 3, which plus or minus, which we can write as 7/3 plus or minus the square root of 2. And those are our answers.